Hi, Ingo. Welcome back.
Hey, Adam. It's good to be back so soon.
Yeah. We stopped with Visual Studio Code, Kotlin. I think that one of the killer use cases for Kotlin multi-platform, I would say, and JProfiler, right? So to wrap up what we discussed, how you were able to integrate JProfiler with Visual Studio Code, and the cool part is that you can have both application open, so you can unit test in Visual Studio Code, and it manages the focus and the window management of JProfiler. So you can work on one monitor or two, it doesn't matter. And which is incredible. I think this is one of the first, right? Java profile integrations with Visual Studio Code, I guess.
Yeah, I haven't seen any other ones. Of course, you hunt around for inspirations and how to do things, but I couldn't really find anything. So those were all like things that I had to find out myself.
Yeah, because you didn't mention this the last time, and I thought about this like the first time, which is a really interesting case because, as my opinion is, Visual Studio Code is not that good, but it comes with all possible integrations, so it became a standard because of the integrations, not because it is a very good IDE. It is more like an editor, and which reminds me of Eclipse. It was the same story back then, right? So Eclipse was popular because of the plugins and all the stuff. Not necessary. Eclipse started as very good editor because it was different story because it had built-in refactoring. This is what I really like. Eclipse, I remember it was early 2000s, and then the plugins came, and then became even more popular. But Eclipse out of the box was introduced an incredible Java experience for me. So better than the commercial IDEs.
Back to then also Swing was incredibly slow, and people were looking for alternative toolkits. And then SWT was like something better than Swing at the time. Then the story changed with several optimizations they did, and also with the hotspot VM developing, and so that was actually also one of the major points where I think why people went to Eclipse.
Okay. And what I didn't like about this age of SWT is, from my perspective, SWT had a terrible API. It was really bad. If you knew Swing, you ever looked at SWT?
Yeah, absolutely. Because of course I also developed the profiler plugin for Eclipse. I know like the APIs of all the IDEs. I'm not a super expert there, but I'm quite familiar because it's not a trivial plugin. So I had to develop some SWT as well. You're right. This is not something that you would like invent yourself, but they had reasons probably.
No, very good, because I thought I'm that strange, and you are, and I build, just an enterprise apps. It's not like, so you have far more experience than I do, but I actually never liked this. And what I really didn't like about the time is, and I attended lots of conferences, and sometimes I attended talks from other speakers, and everyone's so excited about SWT. And I say, okay, you can maybe tell it is faster, or it feels better than Swing, but you cannot sell it as a nice thing for developers. It was like, and this is what I never got, and this happens over and over again, right? I don't know whether you encounter something like Hadoop, where also the big data or whatever, and the API was also terrible. I mean, back then I used Java E and Jakarta, and they say, okay, the API is not that nice. And I look at Hadoop, it's like, this is like, heaven, what we have with EJBs and in the Hadoop era. But just SWT, and an improvement was JFace, I think, right? Was it JFace? This was the, yeah.
It's like the SWT, which is only native, and then JFace was like, then they saw, you can't have everything native. What about a tree? There is no native tree component in Windows, really. So you have to kind of draw the pixels yourself, and then that's what JFace does. Is like it does basically something like Swing again. So
yeah, exactly.
It was the same story. So they didn't really invent anything new then in the end.
Yeah, and because and the last history story is because I saw modules in JClassLib. And back then, Eclipse projects. So I remember I was in an enterprise project, and the architect demanded plugins, but there was no need, because it was like monolithic enterprise application, and there was no concept that a user will replace something. They got what they got, and the release was dictated by product management. So there was no idea. So there was usually plugin. That you need a plugin like import, export, or something, and the UI. But I couldn't find any reason to use plugins. And but the architect wanted to have. So at one point of time, I asked him, "No, how many would like to have?" So if you say 5, so we will, say, okay, then we will find reasons to have 5 plugins, but it will cost us, 1 week more. So let's say 2 days per plugin, right? And he didn't like my way of thinking. And but the funny story was at the end. Because of I don't know what, but we had to disable the plugin mechanism in production because they were afraid that the users will install a new stuff, which was not allowed. So this was actually this was really strange story, because back then everyone wanted to have plugins at conferences. Yeah. In enterprises, this was actually forbidden to use plugins, and it was really hard to find enterprise use cases for plugins. Except I had a chat, but it was a NetBeans project with Sven Reimers, and I have actually to invite him. And he created with NetBeans an IDE for satellites, more or less, and the plugins were signal processing units, where he could, plug different plugins for different signals, which makes absolute sense. It's more like a Photoshop for plugins, right? So, okay, pretty cool. So I installed JClassLib. And my first surprise. So today we will talk about JClassLib. You know this, right? So this is like
yeah, absolutely. Yeah.
You created this, and this is almost 3,000 stars on GitHub, which is incredible. And I installed that, and the first surprise was it's actually the second line on GitHub. Brew install JClassLib bytecode viewer. So I immediately did it because I like homebrew, and I was actually curious what happens, and something interesting happened. So it installed the application, and then I started to try to start it from command line, but it couldn't find that because it was installed as an UI. So this is actually incredible. So it installed a Mac app, a native Mac app, as a homebrew, which is not that common, I would say.
Yes,
maybe you should. Yeah, you should maybe write a one-liner that it actually installs a real app, because I thought, this is like the Java story that you will have to do like Java whatever, and I said, okay, this is strange. This is just a native app.
I don't do that. It's not. I didn't publish that. So somebody else did. That's not my.
Okay. Because I thought that this is done with your install4j.
No, it is not. No. This homebrew is a different thing, and somebody included that in homebrew. I have no connection to that.
but it worked perfectly, and great. The UI is really nice as well. So I assume it is Swing behind the scenes.
Yeah, absolutely.
Yeah. And what I think is that the Swing could come back. I mean, because it feels way better than Visual Studio Code. It is easier to program. So I think now it's time to have Swing back, if I think about this. Because I saw this several times. The Brock is completely implemented with Swing. It looks nice. IntelliJ always looked nice. NetBeans looks like it looks, but it's very fast. The JClassLib looks really nice. And I say, maybe it's time, to do something, because all the arguments against Swing, they were actually since 2006, I guess, never true, because it had really nice UIs. It was really fast. And at the beginning, it was slow. Well, everything was slow at the beginning. But since 2006 or 8, something like this, around Java 6, it improved a lot, right?
Absolutely. So, like, the main thing is, of course, that people always say, Swing is ugly. And then that is a point, because if you use the default look and feel that is in Java, you can look at it and say, man, I mean, couldn't you come up with something better than that? And that is perfectly valid. But there is, like, I think today there is one look and feel that is really, really good and is actively maintained. It's called Flat Laugh. and that's what I use in JClassLib and also in our products, which is very customizable also and has great functionality also to make things more modern. Like, for example, if you use it on Windows, you will see like the menu bar goes into the title bar and stuff like that. Things you expect from modern desktop UI that Java doesn't really provide out of the box with AWT. You get that with FlatLav. And so if you use the Java plus FlatLav combo, you can have a really modern, fast Swing application. And the Swing API is also as it is, but it's not so bad. Yeah, it's of course when things are new, they always have this benefit of being new and more interesting and so on. And Swing is very old, but it's not a bad API if you consider everything. Of course, it has its warts and things where you say this is wrong, this should have been done differently. But any big system has that.
Uh-huh. Just looking at the FlatLav, this is part of the JForm Designer on GitHub, and you were one of the sponsors. So you are mentioned EJ Technologies on GitHub.
Yeah, I'm one of the sponsors. I think you should give back a little to an open source project that enables your success. And so I try to sponsor these projects that I depend on or that benefit my products. And this definitely is one. I also contributed quite a lot of fixes there, so I'm familiar with the code base, and I really like that project. And I think every UI everybody who wants to develop a UI should know about this project and should be the default go-to. And this, of course, difficult. Like if you just start out with a Swing tutorial, they will not mention this, and that's a pity because you really need this to look nice. And if it doesn't look nice, then people will just dismiss it.
Yeah, you're absolutely right. So maybe what should happen, right? So maybe we should ping someone that they should mention something like this, and maybe even use this as an alternative in OpenJDK. I mean, this is in the realm of possibility. I mean, I know this is harder because lots of projects are running on Swing, but in a longer term, why not? Because even a small CLI tools. By the way, you are number 3 contributor to FlatLav. The first one is Def Charlie.
Yeah, that's the guy who develops it, Karl Tauber. He's a guy from Munich, from in the vicinity from Munich as well. So pretty close.
So and yet it's incredible. So I would say such, because if I'm building CLI apps, right, for automation, so I have two options. I can provide command line arguments, or I could open a new UI and have quick access to the UI. For instance, what I could do is copy and paste something from web, JSON or XML, and the UI pre-format this and use it as an input. Way nicer than CLI. And for such small things, Swing is actually incredible. It ships with Java. And JavaFX is the next step, but not even needed for small things. You can just use Swing.
Yeah, the JavaFX story is also like an interesting story in this UI thing, because like everybody thought this is like the replacement for Swing, and it will they will sort of deprecate it and then remove it from the JDK. That was like a common sentiment, and many people thought this. And then JavaFX was actually added to the JDK and was shipped a long time. By default, you had JavaFX in there, and then they took it out again. But Swing is still there, and they sort of cannot really remove Swing. You have this Java desktop module, which is like a huge monolithic thing that is really difficult to split up, and they won't even try to do that. And so Swing has like this pretty secure position in the Java module system there. And JavaFX is, again, something like an external project that you have to bring in. There are some JDKs that bundle it by default. There's the Liberica JDK. Zulu has that. Also has a version of the JDK where JavaFX is bundled. But yeah, it's like you thought this would be the future, and then it sort of is just one option now. And this the narrative can change around these things. And the idea that Swing is deprecated and will be removed, I don't think that you anybody really thinks that anymore. Of course, it's not like anything that people are really very interested in desktop UIs, but it's a solid option, and that's where it is, and it really works. And there's so many things that it does well that would be really, really difficult to replicate with a new system. As also people have seen with JavaFX, it has taken a very long time to do all these things.
Just interesting side note regarding PlatLab. So they have almost 4,000 stars, which is also incredible. But the Dev Charlie has only 64 followers. So I mean, this is no.
Yeah,
this is
he should get a lot more followers, and he should get more sponsors. I think lots of projects are using this and are not sponsoring. So if you use this, please contribute a little, because that accelerates new features and so on. I think that's very important.
Yeah, and WiseWeek could come back, because what I observed is even Mac or Swift UI apps or whatever, they became simple. So the problem we had with Swing back then is it was like an app with 30, 40 tabs sometimes, enterprise apps. And, you had to implement state management and stuff like that. So the tabs were very common. And this is basically gone. So most of the apps, so instead of having one huge app, what tends to happen that you have a smaller apps instead, dedicated apps. And for that, you can achieve with Swing a lot. So you can actually just pick, a JFrame and view JPanels, and you are basically done. So you don't need a huge, architecture for such a thing, which was different back then. I remember there were issues with, memory, how to register and deregister listeners, and then, the threading. So back then, interestingly, the apps were more complex. And even now, if you have LLMs and AI, the apps maybe become even more simple, because some apps will have no chat interface or very simple input. So I think Swing could and should come back, and JavaFX as well, and because they are very useful.
Absolutely. Yeah, and as you can see, like for a tool like JClassLib, this is perfect. It's already in the JDK. You don't have to. You have it on all the platforms, which is also like a problematic thing with SWT and JavaFX. You have to make sure to ship the native libraries for all the platforms where you want to run on. You don't need to do that with a tool that is with a library and a toolkit that is in the JDK, because the JDK will have to make sure that the native libraries are there. So it's a lot more convenient for the developer to say, okay, just program it. I don't worry about the deployment and where it can run. So that is a huge plus there.
It's way easier to install and manage than Electron, for instance. And what we could also do, similar to Electron, which is a web-based UI, is even crazy stuff like you could have JavaFX web view, load the app there and interact with it. It will also work. So there's a lot of possibilities. But why I'm thinking that much about that? Because Java is actually very easy to install. If you compare Java installation with Node.js or Python or whatever, I constantly have to do something in this ecosystem. And in Java, it is actually just delete it and install or download a zip and extract. So actually, the installation story in Java is incredible first. So it is this, I would say, the simplest environment. I think maybe C is simpler, I don't know. But from Java perspective, it's the simplest possible thing where you can download or install with basically one click. Extract zip, you can have a DMG, and then you only need this in path, basically. You need the Java in path, and you are done. And the class path, so what also happened, Java became more powerful, so you don't need that many external jars. So I have a lot of projects without any external dependencies. And currently, we maybe even get JSON in Java. So they are thinking about this. And if we get JSON, I mean, this is the last thing I need from time to time. And then, you have a self-contained apps, which are patched by your vendor of your choice, Zulu, Oracle, Liberica, or whatever. What is the company behind Liberica? There's a different name, right? It's not Liberica.
Bellsoft.
Bellsoft, exactly. Bellsoft or IBM. And they will patch the JDK for you, and you are basically set. This is a huge advantage over the other platforms.
But also, like, you have to consider that in the new world, in the module world, this idea of having like the pre-installed JDK on your computer that other apps will find, also with a fast release cycle that you have so many versions differently from before. People tend to not do that a lot anymore, except for on Linux environment. So they all have these private JDKs that are bundled with their applications. Like in your application, you have this your own JDK that will not publish or let anybody else use or advertise for usage at least. And then you can use like the module system of the JDK to trim that down and remove all the modules that you don't need. Because you say, I'm not doing any cryptography, so I'm going to not have all these modules around. Don't ship that. It's a command line application. The Java desktop module can go and so on. So you have your own modularized environment, and you can make that quite small actually, which is also like that's the one good feature I think from the module system. I have many reservations for what they did with the module system, but that is really nice. Is the deployment aspect that you can trim the JDK to something that you can ship, which is not so huge.
Or you can even use JLink, JLink?
Yeah, JLink. That's it. You use JLink to make it small. That's the tool to like create a new a Java runtime environment. So the JRE used to be something very definite. You used to know what the JRE is, and in the new world there is no JRE really anymore, because it means like the things that you need for your application, and use JLink to trim it to your requirements, and that I think is a very good thing that they did.
Also for security, because you only ship modules which you really need, and all the other modules you don't care, right? So it's
and you have and it makes like if you use a shared JRE for where you say I have this version installed and several apps use it. That in the modern world is a recipe for problems often, because then one module is missing. Is that really the version that I want? So I have a range of versions that I pretend to be working with, and I can only find this, but I haven't really tested it. But if you ship your own JRE, trimmed down JRE, then that's the JRE you can really run all your tests on and be sure that it actually works. So I think that's modern.
But in my opinion, the problems with the shared JRE were only because there were some apps which installed older ones. For instance, Oracle, right? So if you installed Oracle PL SQL client, sometimes I got a very old one, so old that everything broke then. You had to know that. And developers use strange external APIs which need some hidden features from older JDKs, is also a problem. But if we would implement a more reasonable apps, with more modern JDK, I think right now it would be not a problem, because if you say, okay, it has to be higher than 21, and then you are set. You only have the problem, because right now, my impression is that JDKs get more and more compatible. They have more and more features. But there was some, with Java 8 is a huge one. Then JDK 9 with the modules was a huge deal breaker, right? But now everything is settled. So I would say since 17, 17 was already okay, and Java 20.
That's my impression too. Yeah. 17 is like the threshold where you say, okay, things have settled down. Took a really long time. From the 9 was major churn there.
Yeah.
And, lots of problems. And then they also in the subsequent releases, we as tool vendors, especially with JProfile, and so we really had lots of work with that. And now it's pretty good. And also, like before in Java 8, you could you could access all the private implementation classes in the JRE and use them for your own purposes. Like famously the base 64 encoder, which was not meant for public consumption. It's not an API, but everybody uses it because you need it. Often.
But now it's public, right? So we have a public encoder, base 64 and decoder, and this is a public API right now.
Now it is a public API. Yeah. They made it a public API because, they saw people need it, and they removed access to all these internal APIs with the module system. So you cannot use any of the internal implementations anymore, which also that's one of the main things that broke all the applications out there, because people always use these things. But now they took the things that people most used and made them public, which is a good thing. And they then have this permission thing that you cannot use any implementation classes. And now that makes it sort of safer to assume that your app, if it runs with 21, it will also run with 25 or 20, whatever, with any future version. And that's
Do you know when JDK 1.9 was released? Estimations? You remember?
It's a long time ago.
Year, roughly. Just roughly, feeling.
Roughly feeling. It feels like 8 years, maybe.
It is exactly 2017.
Yeah.
And Java 17, 2021. So it means good times. Since 4 years, we are very compatible.
Yeah, absolutely.
And it's also my feeling. And I think maybe we should promote a little bit more the idea that you can use Java 21 as base, J-Link, and create incredible desktop apps for whatever purposes. Again, I do it all the time, and I'm stunned how easy it is. Comparing to the other. I had to update recently, a Node, and I was like, why? I mean, maybe you say, okay, JavaScript is very important because it runs in browser, but you cannot argue it's simple or easier or easier to maintain, right? Than Java is. So this is
certainly isn't. Yeah, it's just. I mean, of course, a certain tech stack, and once you know that, you tend to, you want to use it for other things as well. It's difficult to have 2 or 3 tech stacks to be really fluent in. And people who come from the browser will naturally tend to use JavaScript for everything, and then that's what happens. But as we discussed last time, you can cross over. You can come from the JVM tech stack, and if you know Kotlin, you can do the multi-platform compilation into Node.js, and you don't need to know a lot of JavaScript at least to do that. Yeah.
So you create JClassLib, 3,000 stars.
That is very funny because that's actually the stepping stone. It's older than JProfile. It's the stepping stone that brought me to consider developing a profiler.
And why you started with it?
Yeah, that was in 2001. So it's a long time ago. I already had learned Java. I started with Java in 1998 something, but and developed a couple of successful applications for companies that I worked for, and then I started getting interested in the internals of Java because I'm a physicist,
Okay. I wanted to ask you this because 2001 I was happy that I deployed some EJBs to the application servers, and I would never get the idea to parse the bytecode. So because for me it was like mission impossible back then. So I could try. I knew Cafe Baby, and this was enough. And but I say no way. So I always admired people that like you to create such tools. For me, it was impossible to.
Yeah, it was like an instinct based on I'm an experimental physicist by in university, and you get these things like the internals. You get hints at them, like if you have a method not found error or something like that, you see the signature, which is sort of strange, things like that. And there is this class file that the compiler compiles, but what does it really contain, and so on. And I bought the Java language spec and also the Java class file format. Those were paper books then I bought in a computer bookstore, all these things from the past. And I read that and I found that really interesting because I'm not like a computer science guy, so that was like all new stuff for me, and it was really super interesting for me. And I started using since Java 1, they had this disassembler in the JDK. It's still there.
Java P, right?
Java P. So with Java P, you can look at all the internals of a class file. It shows you the bytecode. It shows you. Back then, in 2001, it was a lot simpler, and it didn't show you a lot of things about the attributes, for example. I recall that it didn't show you that. It was very basic, like to see the which methods are in there, which fields, and so on, but not a lot more. And
now it looks almost like method stub. So it looks like everything without the method body.
Something like that. Yeah. Now, right now, today, it can show you everything. You can see the constant pool and so on. It has all these options and so. But it's a command line tool, and it's kind of difficult to get an overview what this structure looks like. And I thought that, man, this is really a nice tree. You start from the top. You have this tree. It branches down. It has all these leaves and nodes and so on. You could really make a UI just to see that, how the class file format is how a parser sees this class file format and what is all in there. And yeah, I started doing that just like a side project. And it also, at the time, it was pretty manageable because the class file format was a lot smaller back then than it is today. Today, there's many more different kinds of attributes, also different kind of structures overall that you need to parse and understand to. Even the module system introduced a lot of these structures. I really don't know why they did it that way, but introduced a lot of new structures into the class file format. So back then it was a manageable project, and I did that, and I wrote this viewer, and it was actually immediately pretty popular with people. And the NetBeans guys back then, I was a NetBeans user in 2001, of course, because what else would you have been? And then the NetBeans guys liked it, and they thought, they could. I was talking to them and said, "Yeah, do you want to integrate that into the NetBeans project?" And they said, "Yes, that's good. Let's do that. Let's make it a module and so on." And then I was I thought, okay, but then I would like some recognition, like put my name somewhere, that I contributed this. And they didn't want to do that.
Really?
They didn't want to do it. They said, no, it's just this open source. It's not how it works with us in our project. And then I didn't do it. So that was like a historical accident, because otherwise that would have been, my project would have like just merged into NetBeans, and who knows what would have come of it. But I didn't then do that. I said, no, then I keep it as a standalone project. It's a vanity thing. I wrote this code, and I wouldn't be sort of have this recognition that I wrote it. And so I kept doing that as a standalone project. But then I was so, like, it gave me this view into lots of internals in the JVM, and the APIs that didn't know that existed, also the native side, how you could like write agents and so on. That was also something that was interesting for me. And then I had this experience, like in my job, like using a profiler is super useful and so on. And having this experience from JClassLib, I thought I can do this. Yeah? I can do this. I want to do this. I have some different ideas on how to do it. And that's when I started with my brother doing this. My brother is also a computer scientist, so a good combo there. And then that was something that we thought, yeah, we can do this. And this, of course, this is then the beginning of the JProfile project.
But I kept doing maintaining the JClassLib. Looks like
absolutely, because it's. The class file is an important thing for a profile. It needs to understand the class file. We need to instrument classes. So a profiler, when it loads a class, and that's one of the main things it needs to do. It needs to put instructions somewhere to measure things. And
this is why you can write with JClassLib, right? So
yeah, but we don't use JClassLib, of course, because like the profiler is a native agent. It has to do that native code. But it was kind of a learning step. But the writing, actually, JClassLib has this module where you can read and write bytecode. But the writing, actually, I did that mainly because I thought, I need to test this somehow, that the structure is read correctly. So I'll write it back. So I'll immediately write the code to write it back, and then I can read all the classes in the JDK or in the JRE and write them back and see if they are exactly the same. And if I do that, then I'm fine. So that's one of the main tests that I have there, to see if I get everything correctly. So I did that from the beginning. But at that time, there was no ASM, for example, which is like today the code you use to manipulate and has this visitor pattern, which is suitable for modifying
ASM became almost standard, right? So now ASM is
Yeah,
like,
absolutely. I mean, you use ASM, byte body. These are the things that you use as different layers. And so I never positioned this code to be like a code manipulation library, but you can modify things and write it back. But it was not my intention to do that. It was like really just a thing I needed for the bytecode viewer. And there were things back then, something that doesn't exist anymore. But I didn't really like it, and I also just wanted to write my own library to get the understanding of how this all works, and so I created that myself.
I took a look at GitHub, and your first commits were in April, end of April 2001.
2001, yeah.
But it's interesting that this is on GitHub, so it meant you probably started with Subversion and converted to Git at one point of time.
Yeah,
right?
absolutely. I mean, that was SourceForge back then.
Yeah, exactly.
It exists, of course, but those were the SourceForge days. And at some point, I don't remember when, I moved the whole thing to Git. And there was no Subversion back then, because there was no Subversion in 2001. It was CVS. It was even older days. Huh? So it's the third source code system that it's on. But it's really nice how GitHub preserves all these things back and gives.
I think Subversion came 2005, right?
Yeah, 2005. Yeah.
Something like this. Okay, so what I did, I decompiled. I compiled a class, and then opened with JClassLib and took a look. And what surprised me is the hierarchical view. So what you could do, you can look at the constant pool methods, and you get very detailed view. Looks nice, and this the attention to detail is really good. But what I was surprised, you never see the decompiled source, right? Or is it?
It's not a decompiler. It's like a disassembler, which is like a different thing. Yeah, it's also like Java P. It's the equivalent to Java P. Java P will also not show you any source code or something that it tries to cook up, but it will just show you the internal structures in a human readable way, and that's what JClassLib does. It's mainly just a tool for understanding what the compiler produces. So if you do things like developing a profile, you want to understand what did the compiler produce, where can I insert my hooks and so on, and you need to really see what is there and how can I do this. And so there is no decompiler, and I don't plan to do that.
Why? So what I also saw, it is a plugin for IntelliJ, is also popular. Yes. So it is highly rated. So the question is, why you got so many stars? So what people are doing with it? Because 3,000 stars, it means they.
I also wonder.
Because if you think about this, what it means to me, there at least 30,000 users who use that or like that, and what they are doing with it. Because I have some ideas, but they are maybe valid right now. But what they did before, you have some use cases what they did with it? Because not everyone tests compiler, So this is interesting, but
I think it's a lot has to do with learning about the JVM, and
maybe students in science courses.
There's lots of students who learn about the JVM who like this, so they can look at the internal representation of a compiled Java class file, because it's an important thing that if you learn about in a computer science way about a language, then this intermediate representation. This is a tool that you can use to just look at it, and I think that's the main thing. And the second thing, maybe, you can actually edit class files with JClassLib. If you have a string in there or an integer value like a constant that you don't like, you just go into the constant pool, and you can then edit these things. And that, of course, is sort of hacking class files to try something out. And you can even go into the methods.
Maybe
change the
licensing.
sort of course, don't use this to defeat any licensing mechanisms or so on. That's not good. But you can use it for experimentation in the JVM, and you just click on the if you go like to look at a method and you then see all these things, iLoad, ALoad, array length. You click on these instructions, and it tells you first. It says show the JVM spec, no, in the context menu that you see, so you can learn about this. So you can immediately read up on what does that mean. What is invoke static? What does that mean? You go and show JVM spec. It opens the spec and you can read it. But there is also the replace opcode. So you can do replace opcode, and if there is a compatible opcode that you could put in there, then you can replace it. So it's not like it's not an assembler really where you can write anything you want, but you can replace things in a compatible way, so the class file format will still stay the same. And there's things you can do to make this to change the behavior of what the class file does. Because you cannot just like put any instruction in a method. It will destroy the stack map table. There's this pre-verification step that they introduced in Java 6, where the compiler already produces this very complicated structure that is also something you need to parse in such a disassembler. Where and if you change your bytecode in an arbitrary way, then the stack map table will be broken, and the verification is also invalid. So you need to take care to modify it in such a way that the stack map table is. That's what JClassLib supports there. But it's a kind of low level hacking. I think that some people enjoy, that they have the capability to modify these class files after effect in such a way, which would otherwise be messy. To like, how do you do that otherwise? It's not so easy if you don't have source code.
You took a look at Brock, what I told you, Brock.
I have this on my list, but I still didn't get around it. But I will.
Because what they did is they, in order to provide context for LLM, they provide method stubs. So this is similar hierarchical view with some comments, and they pass it to the LLMs because the structure and the implementation. If the method is named nicely, the implementation is not that important. So in order to save the tokens, they created a summary with that. So you could also use JClassLib for that, for instance, because you only care about the signatures and the types and not the implementation, for instance, right?
Mm-hmm. There's some people who use JClassLib also like for this purpose, just to read a class file, get some method signatures out of it, which is like you usually use ASM for that. But yeah, good. Sometimes the visitor pattern is not convenient. If you say, just give me a list of these methods, then the JClassLib API is nicer because you just parse the class files, they get methods, and you have a list of methods, which is much more direct than that's. So for these very simple use cases where you just need to look at some structures, then that would be. I use it also in my other applications, install4j and JProfile. I use the JClassLib library to look at method signatures mainly. So that's looking at, if you want to look at method signatures, then I think the JClassLib data module is very good. It's also very small and it's extremely fast, of course.
What you did in the source code, I do something similar. It was the first time I saw this. So you provide high-level description of the modules in package.md. The question is it like a Kotlin pattern, or is it your way to do this?
You mean the Docker?
If you go to the source code of JClassLib and you go, for instance, to the data module, what you did, you have a package.md, and which, for instance, defines the responsibility of the module. And I do exactly the same in Java with package info. So what I have, all my high-level business components ship with package-info.java, and I use Javadoc to document actually the responsibilities of the module and do something similar with package.md, and was nicely described. So you did it. You do it always this way, or is this Kotlin pattern, or someone else did it?
This is Docker. So Docker is the Kotlin Javadoc equivalent, where you want to produce like this Javadoc-like output. Kotlin has, of course, a lot of different problems that it needs to solve from the JVM, like all the platforms that you have and so on. It's different. It has to use it, and of course, it has completely different concepts that it needs to describe in its documentation. So they have their own standalone documentation thing, and it's called Docker. So it's Dokka. That's how it's spelled, and they are this all in Markdown. So from the start, of course, because it has been created a lot later than JavaDoc. Now we get Markdown in JavaDoc too, but it's that's the yeah. This is analogous to the package info.
Yeah, because it's underappreciated, and I in a bigger project I always had a problem. Not anymore, but a few years back. All public methods has to ship with JavaDoc, and some methods don't make any sense, like getters and setters or constructors or enums. But the package info was underappreciated. No one cared about that. But this is actually more important to me than public method, because I can write this module is responsible for, and these are my thoughts, and this is enough for me to remember why I did it, right?
Mm. Yeah, absolutely. Just things that people don't know. Also, yeah, it's difficult to find out in the IDE that you can do this, because like the rest of the JavaDoc, the IDE often presents you with the option to add something there, but package info is a separate file. You have to know that you can do that. Yeah.
Perfect. I think we covered JClassLib, right?
Yeah, I think we did.
And people should download ClassLib, play a little bit, but actually should buy a license for JProfiler. And then Visual Studio Code integration, try that out and give you feedback. And I like your pragmatic way, actually, with the Swing and Visual Studio Code. And just keep doing Java. It looks great so far. And the last time, what I also forgot to mention, I mentioned it once, the first time I really saw, the killer feature of Kotlin, because not about syntactic sugar, with the multi-platform, you were able to nicely integrate with Visual Studio Code, which wouldn't be possible with Java, or it should be harder with Java. Then it was really an elegant solution. So this is what I search for. Not pragmatic, maybe elegant. Mm-hmm. Thank you a lot. Where people can find you? EJ Technologies, ej-technologies.com.
EJ-technologies, yeah, that's it. And JClassLib, if you just enter it, you come to the GitHub project and you can download from there. That's also very easy to find.
What I missed is you should add a GitHub logo from EJ Technologies to point to JClassLib. It makes better impression that do something open source. So there is no link to GitHub from EJ Technologies.
Okay. Now. Yeah, let's do that.
Yeah, perfect. Thank you, and see you next time.
I have to thank you. Thank you. It's very, very nice to have me.